Each of 311 people who purchased a Honda Civic was classified according to gender and whether the car purchased had a hybrid engine or not. Okay, look at the table. So you have hybrid, not hybrid, male, female. So I will use letters. For the hybrid, I will use H for the hybrid set. Then not hybrid, you can use H complement or another letter. I use NH. This is NH. Okay, this is not hybrid. Then male, I use M, and female set, I use F. If you were to randomly select a person from this group, find the probability the person chosen will be female driver. Just asking the probability of female driver. Probability of female driver is this equal. How do we find the probability of female driver? Number of females. How many number of females we have? 117. 117 divided by total number of um, people. How many people we have, or our sample size? 311. Therefore, this is 311. So this should be 0.376. So that is the probability of female driver. Similarly, you can find the probability of male driver. Then actually 194 divided by 311. And also you can find the probability of hybrid. Let me show you that probability of hybrid engine. So how many hybrid engine? We have 111, then total 311. So 111 divided by 311, it is 0.357. So that is the probability of hybrid engine. If you were to randomly select a person from this group, find the probability the person chosen will be female hybrid driver, or will be a female hybrid driver. Okay, what is the question? First understand the question. They are asking female hybrid driver. It means it should be female and also hybrid driver, hybrid engine, right? Female and also hybrid engine. So they are asking the probability female and and hybrid. Female and hybrid. Okay, how do we find the female and hybrid? So this is the, you see female, this column, sorry, this row, and hybrid, this one. So this is the 34 number of female hybrid driver, then divided by total. Okay, number of female hybrid driver, then divided by total, then 34. Really, uh, let me use same color. um, 34 34 divided by 311. 11. 34 divided by 311 is 0.11009. 0.109. So this is the probability of female and hybrid driver. Part C. Find the probability of hybrid given that driver is a female driver. Okay, now look at here. Find the probability of hybrid. So that is the main part. Probability of hybrid. They are asking probability of hybrid. Then you have a condition driver is a female driver. Okay, therefore we have conditional probability female. This is the probability of H given F. Okay, what is the equation for this? Always we can use this equation probability H and F divided by probability of F. Okay, probability of H given F equal probability of H and F divided by probability of F. So this equal, you can find the probability of H and F. Actually we know over here, but if you go to the table again, you can find this female and hybrid 34 divided by 34 divided by 311, and probability of female, you know, we have 117 total, 117 total female, and the total should be the 311. Actually you can write down this one also just 34 over 117. So it's the same thing because denominator of this and this one are the same, so this cancel. So just write down this. So this probability H given F equal 0.296, 0.296. Similarly, you can find the uh, other way. Let me explain that. How do we find a probability of female given hybrid engine? Okay, this should be the same way probability of female and hybrid divided by probability of hybrid. So this case, you know, this one same probability of female and uh, hybrid. So you can write down the same way, but I will write down female and hybrid 34. I just write down the just 34 here. Then probability of hybrid. How many probability of hybrid? You see here 111. So this is 111 equal 34 divided by uh, 111 equals 0.109. 109. Okay. Now you see the difference. Actually, the main thing is here given part should be the at the denominator. Okay. Then part D. Using probabilities determine whether the events being female and having a hybrid are independent of one another. Okay, independent part. So how do we check? Actually, we uh, have basically two equations. So uh, let me explain one by one. First, you can use the conditional probability. In conditional probability, you have two equations: probability of F in a female and H, right? Because they are asking female and hybrid, independent or not. Okay, that's the main thing. Female and hybrid. Therefore, we use the female and hybrid. So, if these two are independent, this must be equal to the probability of female. So, actually, we don't know yet this true or not. So, we have to check it. So, now this is the first equation we can use to check independent. Okay, now probability of female given age. Actually, we know the answer for this above. From the above, look at here. Probability female given age equal 0.0.109. Now I will check the probability of female. So probability of female, we have the answer here 0.376. So this equal 0.376. So you see these two are not equal, not equal. These two are not equal. That means therefore these are not independent. They are not independent. Or you can say these are dependent. So I say not independent. These are independent. Not independent. That is the one equation we can use. So then next one. I will use this. Same thing you can use here. Let me explain. Uh, Probability of hybrid given F must be equal probability of hybrid if these two are independent. Okay, so we have to check this. We don't know yet. Actually, you don't have to use the both method, but this should be this or this. Okay, one of. Then probability of hybrid given F. I think we do have the answer. Probability of hybrid given F 0.296. 0.296. Then check the probability of hybrid. Probability of hybrid. What is the probability of hybrid? Um, Let me check. Yes, we do have the answer 0.357. 0.357. So you see these two are also not equal. So therefore these two you can decide these are independent or not, sorry, they are dependent or not independent. So not equal, not equal, therefore independent, or you can say not dependent. Now I will write down independent, sorry, again, they are not independent, or you can say dependent. I will write down not independent, not independent. If these two are equal, then we can say H and F are independent. Okay, you can use these two methods, and we have two equations, and we have another equation um, can be used here. What is that one? So again, this is O. Okay, so you can check probability F and H equal a probability of F time probability of H. Okay, so if these two are independent, then this must be equal. So let me check probability of F and H equal. I think we do have probability of F and H here 0.109, 0.109. Then we will find the probability of F time probability of H. So probability of F we know already, that is 0.376, and probability of H we know already, it is 0.357. So this equal probability 0.134. Okay, you see this and this are not equal, so you can say not equal. Therefore, these two are not independent. Not independent. Not independent. Okay. Again, you can use one of these three method to show any two sets are independent or not.